Good morning and good afternoon, everybody. I'm excited to introduce SEC Financial Document Explorer, our solution to simplifying the way financial analysts interact with SEC filings like 10K, 10Qs, 8K. So in the next 10 minutes, I'll walk you through two architecture, a fully on-prem local RAG architecture pipeline, and then a cloud-based AI service stack. We will compare their components, advantages, challenges, and then dive into system architecture, implementation details, performance metrics, and finally we will conclude the recommendation with a live demo. So by the end of this presentation, you will understand which approach best suits your organization priorities around privacy, cost, scalability, compliance, and let's get started. So in this slide, you will see our roadmap. First, we frame the problem in the introduction. We'll cover up the methodology. We'll set up two distinct pipelines. Then we'll deep dive into local RAG, exploring its component advantage and challenges, followed by the same breakdown in cloud AI services. So SEC filings are dense and lengthy and critical for investment decision. Yet manual review is slow and error-prone. Our Financial Document Explorer automates retrieval, semantic search, and summation to accelerate analysis. We'll focus on 10Ks, 10Qs, and 8K filing, mapping a ticker symbols to CIKs, and parsing document into manageable chunks. These project tests out two modality, the local RAG, which keeps everything on-prem for maximum data control, and cloud-based AI, which leverages managed LLMs and vector store for scale and freshness. By evaluating these approaches, we aim to identify local use cases, local RAG for compliance-sensitive environment, and cloud AI for high-throughput distributed team. Our methodology begins with data acquisition, pulling filings directly from SEC API. We then parse each document into chunks for embedding and indexing. In the local RAG path, embedding and inference occur on-prem using Ollama and the DeepSeek model with FAISS for ChromaDB for vector storage. The cloud AI path offloads embedding to OpenAI API and uses Google Gemini for generation and stores the vectors into the Pinecone. Both pipelines feed into a Streamlit frontend, offering a unified user experience. This head-to-head comparison enables clear comparison of performance, cost, data governance, and trade-off. In the local RAG, we host the DeepSeek model via Ollama CLI on Apple Silicon or a standard server. Ollama handles both embedding and response generation without external calls. For similarity search, we use Facebook's FAISS library or ChromaDB for a lightweight, high-performance vector database that operates entirely offline. The Streamlit framework provides an interactive UI for querying, visualizing document snippets, and refining search parameters. By keeping all of these processes local, we eliminate the network dependencies and external data exposure, and this stack is ideal for air-gap environment or environments with strict data sovereignty requirements. So the local RAG primary advantage is privacy, ensuring that compliance with GDPR, SOX, and other regulations. After one-time investment in hardware and software setup, there's no recurring API fees, making the cost predictable. Ollama and DeepSeek are optimized to run on CPU-only Apple Silicon, removing GPU requirements. You maintain control over the model updates, embedding parameters, and security configuration. Additionally, the modular design allows you to swap in local models or vector stores as they merge, ensuring long-term flexibility without vendor lock-in. In the cloud AI stack, we leverage Google Gemini for LLM inference, OpenAI embedding for API for semantic vectorization, both hosted externally. Pinecone provides fully managed auto-scaling vector database with built-in support for metadata tagging and cosine similarity search. The same Streamlit frontend is deployed on the Streamlit cloud, delivering a global and always-on user interface. This architecture shifts compute and storage to cloud providers, enabling elastic scalability and rapid access to latest model improvement while minimizing the local infrastructure requirement. Cloud AI excels at scale. You can ingest and index enormous archives of filing without worrying about local hardware limits. You can instantly tap into the newest LLM versions, benefit from the Google's and OpenAI's continuous updates. Pinecone's metadata filtering enables precision queries by ticker, filing type, and date ranges, improving relevance. The responses are reference linked to original document section, reducing the risk of hallucination. The cloud environment seamlessly integrates with CI/CD pipelines for automated deployment and updates, and supports global access for remote analysts. The cloud reliance introduces privacy concerns. Sensitive financial data flows through external networks, raising compliance issue with GDPR, HIPAA, or internal policy. There is an ongoing API cost that scales with query volume, potentially $45 or more for 10,000 queries. You will incur network latency, availability risk tied to internet connectivity, regional outages. The vendor lock-in can also limit profitability, portability, customization, as well as proprietary LLM rarely support fine-tuning, although model distillation is available on some of these models, which can be really complex. Managing API keys, permissions, and endpoint security across multiple services can also add a lot of complexity and potential attack surfaces. This diagram illustrates our hybrid architecture. We ingest filings from SEC Edgar API, parsing that splits into chunks for a local RAG, and then basically feeds into Ollama DeepSeek and Feist ChromaDB for on-prem. For the cloud, the chunks go into OpenAI embedding endpoint, the Pinecone with generation with Google Gemini. The Streamlit UI sits in the front with the toggle to choose between the cloud mode. This unified interface ensures consistent user experience while accommodating the backend on the deployment needs. So here's the side-by-side feature comparison. As you can see, in data privacy, local is high, cloud is moderate. The cost for the local is minimal, ongoing, versus the cloud incurs a moderate API fee. The query speed local on CPU is moderate, although it can be increased with the help of GPU. Cloud with distributed GPU is pretty high. Setup complexity for the local is moderate. Cloud is simpler to provision. On the scalability point, cloud is elastically scalable. By matching this dimension, you can align your choices with organizational priorities, data control versions, throughput. In the benchmark with 100 document samples, local RAG on MacBook Pro averaged about 3 seconds per query, sufficient for small to mid-scale use cases, whereas Cloud API averaged of 1.5 seconds per query, thanks to optimized backend hardware. The cost modeling shows that 10,000 monthly queries on the cloud would cost approximately $45 in API fees, while the local RAG is marginal cost remains zero beyond the hardware depreciation. These numbers highlight the classical throughput versus cost trade-off. The cloud delivers speed and scale, whereas the local delivers budget and predictability. To conclude, the local RAG is best suited for organization with stringent data sovereignty requirement, fixed with budget, or air-gapped environment. This offers privacy, cost control. Cloud AI shines for a larger application, distributed teams with rapid deployment and access to latest LLM capabilities. So bet at ongoing cost and some loss of data control. Going forward, we are exploring hybrid model, caching frequent embedding on-prem, and selectively routing queries to the cloud, plus on-prem fine-tuning of open source model to bridge the gap between control and performance. Next, we will look at a demo of financial document on the Streamlit app and see how it works. Okay, let's get into this demo. So this is called a SEC Financial Analyzer. It is currently hosted in the Streamlit cloud. And we can start by putting in, this is a Streamlit UI, where you can add a ticker symbol. So let's just start with Apple. And yep, it was able to find the CIK for a particular Apple symbol, and we do have close to a couple hundred CIK symbols, so this can be used for quite a bit of ticker symbol. We start by looking at the 2024 start year and 2025. We can look at different filing types, so we can look at 10K, 10Q, and 8K. And if we click on the fetch filings, so it should be able to look for 17 files. So it goes from all the way from 2024 to about 2025, which are the most recent filings. So it has downloaded those 17 filings successfully, and it is now creating 17 document chunks based on those filings. What it's doing, it's processing those documents. It is clearing the Pinecone index. So for example, if you have already created an index, it clears that and makes a brand new financial document index. The vector database is built on the Pinecone. And we do have a pre-populated some of the questions that we can ask. So let's go ahead and ask, what are the company revenue in the most recent quarter? And let's just generate the answer. So in the background, the embedding was created by OpenAI, and then this is currently using Gemini. So it says that the most recent quarter, it was about 119,575 million for the last 3 months, ended December 20th, 2024. These are the respective sales per different iPhones, MacBook, Mac. 3 months ended in July, and then it gives you a breakdown of what are the different sales. It also talks about what are the revenue growth, deferred revenue, iPhone revenue, and it also looks at what are the different sources and how it got those different sources from the document. You can even ask what are some of the key risks in the latest 10K. So we can generate some of the questions, some of the answers. So it says the latest 10K 2024, the risks are detailed in part 1, risk factor consistency. Consistent, there has no material changes in company risk factors since 2023. External scrutiny from media, political, regulatory bodies, impact of business, risk factor, blah, blah, blah. And then it also lists out the different sources. So that is for Apple. Now let's see if we can do the same thing for Tesla. So it did find the ticker symbol for Tesla. So let's go ahead and do the filings, fetch filings. So it is found those filings. Okay. It is creating the document chunks. and it is inserting those documents into the Pinecone, and it is building the vector database. So yeah, so this can take a minute. There are 17 documents that has been inserting into the Pinecone, so that is built. Now, instead of asking some question, we can even ask our own. We can say, tell me about the risks so it does talk about the operational risk, international risk, liability, cybersecurity, and some other risks that it has identified. Let's look at the revenue. Okay, so it says it's difficult to find company revenue, but it looks like it did give me the company had a recognized total revenue of $25.1 billion, automotive segment, energy segment, and then all of these other segments that has been identified in the last quarter. So yeah, so that is the demo, and it does reference out where is those documents coming from. All right, thank you.